Department AISSMS IOIT Pune. Let us start a session on cellular concept. This session consists of cell clustering, capacity, and frequency reuse for a cellular system. Let us start. In case of cellular concepts, we know that any region is divided into certain number of hexagonal cells and cluster is formed. Channel assignment is done to one of the that is method either from fixed channel or dynamic channel. But before going into detail of fixed channel and dynamic channel, let us understand channel assignment. Every cell has given certain number of channel. To increase the capacity or to decrease the interference, there are two approaches. In case of fixed channel, each cell has predefined or pre-calculated voice channels and new calls which are coming to that particular cell. If there are unused channels, then further calls can be blocked if they are not utilized, or further the calls can be blocked. So this is the approach, that is rigid approach, in case of fixed channel assignment. In case of dynamic assignment, voice channel allocated depending upon the that is request. Number of that is people coming in the cell are more, than no permanent assignment is done, and blocking probability is reduced in this case. So to have this particular fixed and dynamic kind of approach, just first of all see what is mean by cellular concept. Now to have that cellular concept, first option is either we can have a single high power transmitter that is in the heart of that region or city, and to have the coverage of entire city or region we require to increase the height of the antenna, and it has to be mounted on the tall tower, but here no frequency reuse is possible. Hence, what is to be done is that entire cities can be divided into hexagonal cells, so that we can have no that is space in between. If we take a circular shape, then there can be in between left out region. So we are taking a hexagonal shape, and in that low power small transmitters, with each providing coverage to only a small portion of that area, is taken into consideration. So number of that is transmitters will be high, but it is not a high power transmitters. This is called as a first cellular concept that we have to understand. Now let us say we want to understand this cellular concept and a system level idea. For that we have to take into consideration every base station will be allocated for the portion of total number of channels. There will be number of channels, but that channels are available, frequencies are divided into group of channels, and available channels are relatively small number of that is given to the relatively small number of base stations by taking care of interference of the base station. So same frequency cannot be allocated into the next that is cell. That care is to be taken into consideration. Adjacent uh, cells will not have the same frequency. So low power low power transmitters we are going to use, and that is our that will be our approach instead of using only one high power that is transmitter. Now we use these cells which are having hexagonal. If it would be circular, then there would be a portion left out as we had said, and such a clusters are formed. Like here is a cluster that is formed, and the frequency that is here cannot be used in this particular cell, but this can be used in the non-neighboring cell. So that is possible because of that we are having frequency reuse. Or if person in allocated channels in B, and suppose one person is talking in B region and he has finished his call, the same frequency can be allotted in the same cell to next person who can go over a call. So that is called as a frequency reuse. So both kind of things are possible and it is called as a frequency reuse. Now let us see what is mean by that is how we can have number of grouping of the cells. So we are having duplex communication means on the same time both people are having that is communication to and fro. So for that if we are having S duplex channels and K a group, that is we group them in a k groups, then S is equal to k into n, where n is number of cells and k is nothing but group, that is how many groups are to be done for how many channels, that is the thing we have seen. So S we got here, that is nothing but number of channels into group. Now that S number of channels into groups can be used as a cluster. So m times can we have the repeating structure of this particular thing? Yes, this is 7 cell repeating structure. That is nothing but 3 times it is repeating. So here m will be 3 and s will be this particular that is cluster. So S will have K into N. So how many N are there? 7. So like that we can have the C is equal to MS or C is equal to MKN. That kind of thing we can have. Now let us see uh, the set of frequencies that we want to use in a system level idea, that is we are having this cluster and we have to take into consideration relatively smaller number of base station, that is uh, number of base stations here, and we want to see the capacity of that particular. So we have seen frequency reuse, we have seen clusters, now we have to see the capacity uh, of that particular cells. So the cluster size is n and is typically 4, 7 or 12 or 19. How it comes, that we will see here, and how the frequency reuse factor is there. It is inverse to 1 upon n. N is nothing but desirable, n is nothing but number of cells and it is desirable to have that capacity. Now let us see that how we can have that number that is coming into that is our 12 or 19, how it is coming. There is equation n is equal to I square plus ij plus j square. So it is the very important equation guiding us so that co-channel neighbors of a particular cell will not have the interference. Example, let us take I is equal to 3 and j is equal to 2 and let us calculate it. So if I take j is equal to 2, j square is equal to 2 square means 4. If I take 3, 3 square means 9, 9 plus 4 is 13, plus ij means 3 into t, 2 is equal to 6, 13 plus 6 is equal to 19. I get the that is n is equal to 19. So n is a satisfying this equation and we get that the cellular capacity. Now, how to do this particular co-channel interference, and for that, what is the equation and how the diagram look like? So here the diagram is having, if I do have I cells and I cells are having hexagonal things, then I will move I in this fashion and then in a 60 degree, and then I will move forward in J cells, that is 90 degrees. So I have taken this I is equal to 2 and then I move forward by 3, so that the frequency reuse, I can use this frequency in this particular that is cell. So this is the concept that I have to take into consideration. So this way I can have anything, like I can take I is equal to 1, j is equal to 2 and I can calculate n, and then I can have this kind of that is a diagram where I can see that any frequency that is at A cannot repeat in this cluster, which is not showing the satisfactory equation of n. But if I see that calculation of this thing, that is going further, I is equal to, let us say, 1, 2, and then j is equal to 3, and I can get the replication, or I can use that frequency in another cell. So this is my frequency reuse concept. So what I mean to say is, before we had using only one transmitter located at high height and covering all this area. Instead of that, I have used the small transmitters in one cell, and that particular frequency can be reused in another cell, which was not the previous experience. Hence, in case of this cellular case studies, in a system level idea, I can get a confidence that here I can have the frequency reuse which was not in past. So this way we have seen the cellular concept of that is frequency reuse, clustering, and we have seen how the frequency reuse can be done successfully, and how to increase the, that is, fixed cells, fixed capacity to, that is, we can have more number of things. And so we have seen related to cellular concept all these things. Thank you very much for attending this particular session. I'm Varsha Kiran Patil, signing off from this particular session. Thank you.